Hey everybody, in this video I'm going to show you how to download a LiDAR dataset from the Open Topography website and also make it into a DEM. So we'll start out by going to opentopography.org and then clicking on the Data tab, Find Data Map. And you can see most of the datasets, the LiDAR datasets, are available in the United States, but also some outside of the US. So as you zoom in on the United States, you'll see that there's three types of data. There's USGS data sets available in green, freely available open topography data sets in red that are contributed from various projects around the country, and then community data space projects. So if you want to get access to the USGS data through Open Topography, you do need to sign in with an academic email with a .edu. And I believe you're going to have to create an account and sign in to get any data off of opentopography.org. So at some point you'll be prompted to do that. So the cool thing is, though, there's so many different data sets to choose from. You can explore around, find something cool that you're interested in. For me today, I got interested in Glacier National Park. Up here they have a nice data set. Looks like maybe it's along the Going to the Sun Road. Unfortunately, I wasn't able to actually download the green data set, the USGS. Something was wrong. So I'm going to go after this red one. I'll left click it. It's the Flathead Lake Biological Station. So I can click on the name and it will bring me to the data page. And it's such a great interface here. I'm going to click Point Cloud Data. It's going to bring me to a lot of information about the data. And one of the important things we can see here is the point density, or the shot density. It's about 2.4 points per meter squared on average, okay? So the reason this is so important is it tells you lets you determine what a good target pixel size for your raster DEM will be. A good rule of thumb is that you want to have an average probably of 2 shots or 2 points per pixel. So in this case, if I use a 1 by 1 meter pixel, I'll average about 2.4 shots in that pixel. If you had something like a density of 8 points per meter squared, then you could get away with using like a half meter pixel size. And you can push it. You can push it smaller than that. Just means you're going to end up with maybe some null pixels or some interpolated pixels that are not as accurate. So depending on what's important to you, accuracy or kind of high spatial resolution, you could push the pixel size higher or lower. Okay, so here is the data availability. I'm going to just take a subset of this. So I'm going to hit Select a Region, left click, and try that again. Select a region, left click. I'm going to take a pretty small area. And once that's selected, you can go down further. And I can see that if I download both ground and unclassified points, it'll give me about 62 million points. So what I have found previously is 25 million points gives you about, something like an 80 megabyte file. So 100 million points might give you something like 320 megabyte file. So depending how good your computer is, maybe you want to shoot for about 100 million points, but if you have a good computer, you could certainly go up to 200 or 300 or 400 million points or more. Just you're going to have a much larger file as you go higher. So in this example, I'm going to download, but notice this, if you take off the unclassified, that brings me down to 12 million points. So if you know for sure you only want ground returns, and you're willing to sacrifice kind of maybe some shot density in order to have just the really high quality ground returns, that's going to give you only 12 million points, which is going to be a very small file. In this case, we're gonna actually do this twice. We're going to first download just the ground points, and then we are going to download both ground and unclassified. And we're going to compare the DEMs that are made from those two. All right, so we'll start with just the ground points, the smaller file, and we're going to download in the LAZ format. That's kind of a compressed version of .las, so it'll be a smaller file size. We're gonna not do DEM by tin. We're gonna do DEM by local gridding, and we're gonna go with calculate Z using inverse distance weighted. Okay, you can also do mean or min or max. We are gonna aim for a 1 meter pixel size here, and we're gonna use a search radius of 1.4 meters. These are the defaults. Again, if you have a lot higher shot density, you could make this a 1/2 meter or 1/4 meter in a smaller radius as well. We're going to use a GeoTIFF output format, and we're going to fill the nulls. If there's any pixels that don't have a laser shot within 1.4 meter radius, we're going to fill those with probably the average of the 7 neighbors. Okay, 7 neighboring pixels. And we're also going to put in this is a pretty cool one, calculate the point count. This is going to show us how many laser shots were in each pixel. Okay, so once you got that all specified and make sure you are logged in, give it a job title. I'm going to call it Glacier NP Ground. And it's going to get emailed to me. It'll take a minute for it to actually make the DEM, and then I'll receive an email prompting me to download both the DEM and the LAZ file, the raw point cloud file. Okay, so the processing finished. I got an email to remind me, and also if you stay logged into the Open Topography screen, it also advanced to this download page, which is basically the same page you would get to if you were following the email link. Okay, so the first thing we'll do, we have two data sets. We have the point cloud results, and then we have the DEM results. So in this case, we actually don't really need to download the point cloud because we're not going to show you how to further process those, but if you're ready to do that, you want to get that. In our case, we're going to go right after the DEM. So on a PC, you can right-click and save link as, or you can just click the link and it'll probably prompt you to save it. I'm going to just save it as DEMs. Actually, I'm going to save it as glacier3.tar.gz. And you may also want to download the metadata here as well. This can be pretty useful in terms of understanding shot density and other things like that. So I'm going to also throw down the metadata there just so I have it. Okay, so next we'll need to unzip these. So go to the folder where you saved them and find the .zip file. Here it is for me, glacier3.tar.gz. Right click. I use a software called 7-Zip to extract. I recommend installing 7-Zip if you don't have it already. It's free. I'm going to use extract here. I'm just going to say yes, replace everything if we can do that. So it's going to extract a new file called dems.tar right here. Now I need to extract that again. Right click, 7-Zip again, and I'm going to go extract here again. And it wants to know if I want to replace these. I don't think I can do that because I think they're open here. So I'm going to say no, do not replace these, no. So what I'm going to actually do, I'm going to right click and go to 7-Zip, extract files. And I'm going to put them in a different folder. Yeah, they're going to go into a DEMs folder here. So that way it won't ask me if I want to replace them. Okay, so here they are in the DEMs folder. And actually, before I load those into QGIS, I am just going to go back around, and I'm going to keep in mind these were made using just the ground returns. I'm now going to go and quickly download the same data, but using all of the returns. So if this is still open for you, you can actually go right back and go modify and resubmit this job, which is pretty handy. So it brings us right back to our previous screen. Our selection is still open. And now I'm going to now download the unclassified and the ground points. And we're going to leave all this stuff at the same settings. So now it's going to make us a DEM, but instead of making it from only the high quality ground returns, it's going to make it from all of the last returns. So this is going to include you know, things like trees and buildings and things like that. So again, we're going to say unclassified, unclassified, and we're going to submit the job again, and it's going to kick us back an email when it's done. And then you'll go through the exact same unzipping process, and then you will add those .tiff files into your QGIS project. Okay, so now I have exported the data using all of the unclassified points, and I unzipped them, and I'm ready to add them into my QGIS project. I already have my ground, my DEM and hillshade derived from my ground returns here. Now I'm just going to add the DEM derived from my unclassified returns. So I'm going to hit here. I'm going to go find the files wherever you unzipped them. Here they are. Notice we have two. We have the output.idw, that's the actual DEM, and we have the output.count. That's the number of shots in each pixel. So we're going to add both of those. And what I did, I created group layers so that I can keep these files separate. And I'm going to put these into the unclassified return group. And then I'm going to actually compute a hillshade on the output.idw, the one I just added, and I am going to give that hillshade a file name. Okay, so I forgot to clue you back in, but we did compute the hillshade. It's been added here, unclass hillshade, and we also have, I've renamed these layers, unclass count and unclass DEM, and these are all together inside of a group layer here. Okay, so I've got a group layer for unclassified returns and a group layer for ground returns. And okay, so now what I want to do, I've got the DEM up on top of the hillshade. I'm going to right click, go to Properties, Symbology, Single Band Pseudo Color, and I'm going to get a contrast stretch on it. We'll apply that. Also going to go to Transparency, make it about 40% transparent. We'll hit OK. Good, so now we've got a nice shaded relief. And we're doing all of this so that we can compare what it looks like when you output a DEM made with all of the unclassified returns versus a DEM made with only the ground returns. So it's pretty interesting. Let's start by looking at what's in our unclassified returns, or kind of using all the returns. If you zoom in on this area in particular, notice here we're picking up a lot of buildings and, of course, a lot of trees here. Okay, now if we take a look at what the ground return, the ground-only returns looks like, pretty interesting. It's actually stripped off all of the trees, and it's actually stripped away the buildings as well, which is pretty fascinating. So it was able to tell that those buildings were not actually ground. And if we zoom back out again, there's another really interesting area here, which is over in this area. If you look over here, we can see this is actually a big landslide, which doesn't look like much using the unclassified returns. It's covered in a lot of brush. It's kind of hard to see what's happening. But if we look at the ground-only returns, you can actually see this beautiful landslide headscarp, and you can see the texture of the landslide runout. So here it seems that we've really getting a much better look at the ground by using ground only and not muddying our picture with those unclassified points. So now I will turn it over to you to make your own DEM. Good luck.